Hello, welcome back to another video of the analyst CIA. In this video, we're going to run a new analysis for a crossbow. This is a full transient analysis. The challenge of this analysis is to recreate the tension in the wire. I tried using a wire, however, I had several convergent issues. Then I thought that I can use a spring to represent the wire under tension. The parameter needed for this spring is the longitudinal stiffness, this one. If we get this information from the wire, we can include it in our analysis as input parameter. For the geometry, I'm using rigid bodies for the arrow and the link. For the limb, I'm using structural steel linear. And for the stock, I'm defining aluminum. I'm using bonded contacts in the parts that there is not a displacement. And in the parts that we will get sliding, I'm using a frictional contacts, frictional coefficient of 0.2. Okay. I also define no separation contact for the link and arrow. That it would be working during the first millisecond. Um, I think it's, yes, it's this one. Mhm. It will be working during the first millisecond of our analysis when the spring are under tension. This contact die. For this, I'm using contact step controls. Mhm. And in the last step, other contact there is a frictional contact is active in this case. Okay. Um, of course, that we need to define some joints. In this case, I'm using a general joint, body to ground for the link. I'm allowing displacement in the x direction. In the rest of the axis, it's completely fixed, so there is not a displacement and rotations. Okay, and what else? Okay, also I define the as input the displacement of the arrow and the displacement of the link, both. So this is to achieve the tension. So let's go to the solution. Let's see how it looks. Okay, it's loading. It's in tension, and then we can see how is working. As I mentioned, just the first steps are to make this to achieve the pretension, and then the link will be sliding through this guide, pushing the arrow. Of course, that we can include more steps and more seconds if we want to see uh, the arrow fly away. But that's the simulation. Also, we can take some measurements of the velocity, and also we can see the total deformation. In this case, I plot the stress. Of course, that we are in a very high level of stress, but don't worry, they will not break because I'm using a linear material. In this case, to represent better the non-linearity of the material, I can include or I could include the no linear structural steel, and we can see if we are under the elastic region or in the plastic region of the material. But yes, this is the analysis. I hope you enjoy. Thank you for watching my videos and see you soon.